Okay, so for this video, we will be discussing integration by trigonometric substitution. So as the topic suggests, we will express our integrand in terms of trigonometric functions, okay, by the use of the suggested substitutions. So when the integrand involves a squared minus x squared, so where a is any constant, so we will try to substitute x is equal to a sine theta. If it involves a squared plus x squared, then we will try x is equal to a tangent theta. And if we have a term, an integrand involving the terms x squared minus a squared, then we will try to substitute x is equal to a secant theta. So, but why do we have those suggested substitutions? So actually, those substitutions are supposed to make our integrand simpler. Okay, so let's take a look at this first suggestion, for example. So if we have a squared minus x squared, so try x is equal to a sine theta. So let's just write here, if we have a squared minus x squared, so we will substitute x with a sine theta. So this will become a squared minus x is a sine theta squared. Okay, so that will now become a squared minus a squared sine squared theta, right? So therefore we can factor out a squared. So a squared times 1 minus sine squared theta, and from the identities we know that 1 minus sine squared theta is equal to cosine squared theta. Okay, so with this, so as we can see from a two-term expression, okay, so we have here two terms, a squared and x squared. Okay, so positive a squared minus a squared, so it now becomes a single term, okay, in the form of a squared cosine squared theta. Okay, so with that, so we can simplify the integrand. Okay, so that's the main point of trigonometric substitution. So from a two-term, no, to a two-term integrand, no, from a two-term part of the integrand, so it becomes a single term, no, using the substitution and then the corresponding identities. So similarly, if we do it here, so if we substitute x is equal to a tangent theta, so this will become a squared plus a squared tangent squared theta. Okay, and then factoring out a squared, so that will become 1 plus tangent a squared multiplied by 1 plus tangent squared theta, so that becomes a secant squared theta. Okay, and then here this will become a squared minus a squared times secant squared theta minus 1, so this part here will become a squared tangent theta. Okay, so those are so that's the reason, okay, why they suggest to use these substitutions. Okay, because it is supposed to simplify the integrand. Okay, so say for example, so we have integral of square root of 9 minus x squared all over x squared dx. So this one is in the form of we have here this part of the integral 9 minus x squared, which is in the form of a squared minus x squared. Okay, so for this, so we will try to substitute x with a sine theta. So our a here is a squared is 9, therefore our a is 3. So okay, so take 2. So from the our example, so we have integral of the square root of 9 minus x squared all over x squared dx. Okay, so from earlier, so if our integrand involves a squared minus x squared, so we'll try to substitute x is equal to a sine theta. Okay, so let's note that here. So if we have a squared minus x squared, so substitute, okay, x is equal to a sine of theta. Okay, so in this case, our a squared is 9, therefore our a is 3, and then so let x is equal to 3 and then sine theta. Okay, so substituting that, so our integrand will now become square root of 9 minus x is 3 sine theta squared. Okay, so over x squared, so still 3 sine theta squared. Okay, our dx on the other hand will become, so from x is equal to 3 sine theta, therefore our dx is equal to 3 cosine theta d theta. Okay, so times 3 cosine theta d theta. Okay, so simplifying our integrand, so this will become square root of 9 minus 3 sine squared theta, that is 9 sine squared theta over 9 sine squared theta, okay, times 3 cosine theta d theta. Okay, so we can simplify, so 3 over 9, that is 1/3 integral of, so we can factor out 9, square root of 9, and then this will become 1 minus sine squared theta. Okay, over sine squared theta, and then times cosine theta d theta. Okay, so 9 is a perfect square, so we can take that out of the radical sign. So square root of 9 is 3. Okay, and then what will remain inside the radical is square root of 1 minus sine squared theta, but 1 minus sine squared theta is equal to cosine squared theta. Okay, over sine squared theta cosine theta d theta. Okay, so as you can see, so we have 3 and 1/3, so it will cancel again. So what will remain is integral of square root of cosine squared theta, so that is cosine theta. Okay, but multiplied with cosine theta, so the numerator will be cosine squared theta over sine squared theta d theta. Okay, so but we know that cosine squared theta over sine squared theta, that is equal to cotangent squared theta. Okay, so to integrate cotangent squared theta, so we will use the identity. Okay, so cotangent squared theta is equal to cosecant squared theta minus 1. Sorry, cosecant squared theta minus 1. Okay, so the integral of cosecant squared theta is negative cotangent minus integral of d theta is theta. okay, plus c. Okay, so our integrand now is in terms of theta. So just like the trigonometric substitution, just like the algebraic substitution, so in trigonometric substitution, we will also return the integrand into the original variable. So our original variable was x. Okay, so but how do we do that? So since from the substitution, so we let x is equal to 3 sine of theta. Okay, so therefore x over 3 is equal to sine of theta. Okay, so if we draw a right triangle, okay, and then we identify one angle as theta. Oops, sorry. So if this is our theta, okay, in the right triangle, so sine of theta is opposite over adjacent. So theta, its opposite corresponds to x. In sine theta, we know that sine theta is opposite over hypotenuse. Okay, so sine theta is opposite over hypotenuse. So if this is our theta, the opposite is x, and then the hypotenuse is 3. Okay, so from the Pythagorean theorem, so the other side will be equal to the square root of hypotenuse squared minus the side squared. So it will become 3 squared minus x squared, so that is 9 minus x squared. Okay, so from there we can derive the cotangent. Okay, so since we know the tangent of theta is the reciprocal of cotangent, okay, and then tangent is opposite over adjacent, then cotangent theta is equal to adjacent over the opposite. Okay, so adjacent side of theta is square root of 9 minus x squared, and then its opposite is x. Okay, and also for theta, since we substituted sine of theta as x over 3, then theta is equal to arc sine of x over 3. Okay, so therefore, so using those, so our integral will now become the given, so integral of the square root of 9 minus x squared over x squared dx will now become negative. Cotangent theta is square root of 9 minus x squared over x. Okay, so minus theta is arc sine of x over 3. Okay, plus c. So this is now our answer. Okay, okay, so for trigonometric substitution, okay, so all you need to do is use the suggested substitution. Okay, and then simplify the integrand. Okay, simplify the integrand until you obtain a term which can be integrated. Okay, and then after you have the integral, okay, so express it back into the original variable. Okay, so review your trigonometry. Okay, so the right triangles here. The right triangle is very useful in obtaining the value for the cotangent, okay, of theta in terms of x. Okay, so for our second example, still by trigonometric substitution. So we have here the integral of dx over x squared plus 2x plus 2 and then squared. Okay, so this may not be very obvious, but we can express the denominator in terms of x squared plus a squared. So we just have to be open-minded. Okay, so we have x squared plus 2x, so this actually we can make this a perfect square trinomial. So completing the square, the third term is positive 1. Okay, x squared plus 2x plus 1. Okay, and then we have plus 2. And then since we added 1 there, so we should have minus 1. So this is squared. Okay, so this will now become integral of dx over, this is x plus 1 squared minus plus, so 2 minus 1, that's 1, or you can say it's 1 squared. Okay, so now this is in the form of x squared plus a squared. Okay, so by trigonometric substitution, okay, so we can let x plus 1 as, so our a is 1, so no need to write it here. So a, that is a tangent, am I right? Okay, so here, so if our term involves x squared plus a squared, or a squared plus x squared, so we will use tangent. Okay, so x plus 1 is equal to a is 1, so tangent theta. Okay, so with that, our dx will also become derivative of tangent, differential of tangent is secant squared. Okay, so our integrand now will become, so let's write again our integrand, dx over x plus 1 squared plus 1 squared. This will now become integral of, so our dx is secant squared theta d theta over x plus 1 is equal to tangent theta plus, I have 1, okay, so this will become secant squared theta d theta, so I'm sorry, I forgot to write the squared. Okay, so squared, so I'm so sorry. So we have here tangent squared theta plus 1. So from the identities, tangent squared theta plus 1 is equal to, that is secant squared theta, right? And then squared. So simplifying this, so secant squared theta over secant to the fourth theta. So what will remain is 1 over secant squared theta. And 1 over secant squared theta is equal to cosine squared theta. Okay, d theta. Okay, so this one is case 4 of the trigonometric transformation. So for cosine squared theta, so we will substitute 1/2 multiplied by 1 plus cosine 2 theta. So using the identity, 1/2 times 1 plus, okay, cosine 2 theta d theta. Okay, so this will now become, okay, 1/2 integral of distributing integral of d theta plus integral of cosine 2 theta d theta. Okay, so sorry, I have committed a mistake, so I have to rewrite the solution again. So distributing this, so we will have from here, so we have 1/2 integral of d theta plus 1/2 integral of cosine 2 theta d theta. Okay, so integrating this, so we have here cosine 2 theta. So this part here should be the complete differential of 2 theta, therefore it should be 2d theta. But in inserting 2, then outside the integral sign, so here if we have cosine 2 theta, if we insert 2, then there d theta, so here outside the integral sign, we should write the reciprocal of 2. Okay, so here we will have 1/2 integral of d theta is theta plus 1/4 integral of cosine 2 theta is sine 2 theta plus c. Okay, so just like the previous example, so we will revert the integral back into the original variable. So from theta, so we will return it to x. So recall that later we let, okay, so remember that earlier we let x plus 1 as our tangent of theta. Okay, so doing again the right triangle, okay, so if this is our theta, then since we know the tangent theta is opposite over hypotenuse, opposite over adjacent, so we have here over 1, an invisible denominator. So therefore, opposite is x plus 1, adjacent side is 1. Okay, so therefore, the hypotenuse is, by the Pythagorean theorem, so that is the square root of x plus 1 squared plus 1 squared. Okay, so from this substitution, so we can now obtain theta. So theta from here, it's since tangent theta is equal to x plus 1, therefore theta is equal to arctan of x plus 1. Okay, and then for sine 2 theta, so since sine 2 theta, from the identities, double angle identity is equal to 2 times sine theta times cosine theta, then it will now become 2, okay, sine theta from the triangle. So we have sine theta is opposite over hypotenuse. Okay, so our numerator is x plus 1, then our hypotenuse is x plus 1 squared plus 1 squared, so that is x squared plus 2x plus 2. Okay, so x squared plus 2x plus 2. Okay, and then for cosine, cosine is adjacent over hypotenuse. So adjacent side is 1, and then hypotenuse is still square root of x squared plus 2x plus 2. Okay, so multiplying this, so sine 2 theta is equal to, okay, is equal to 2 times x plus 1 over, so multiplying this, so we'll remove the radical sign, over x squared plus 2x plus 2. Okay, so going back, so we will substitute here theta is equal to arctan of x plus 1, and then sine 2 theta with this one. So therefore, the integral of those are given dx over x squared plus 2x plus 2 squared, that is now equal to 1/2 of theta. So 1/2 theta is arctan of x plus 1, and then plus 1/4 multiplied by sine 2 theta is, so 1/4 sine 2 theta, so sine 2 theta is this, so 2 times x plus 1 over x squared plus 2x plus 2, and then plus c. So simplifying the second term, so we have cancel, so what will remain here is 2. So therefore we can factor out 1/2. I think we have 1/2 1/2 of arctan x plus 1, okay, plus x plus 1 over x squared plus 2x plus 2 plus c. Okay, so this is now our final answer. Okay, so so that's it. So here now we have simplified the integrand. Okay, we have simplified the integrand until we obtain a form that where it can be integrated. Okay, so similar earlier, and here in reverting the integrand back to the original variable, so we still use the right triangle. Okay, and then here we have used an identity. Okay, so it's also important that you recall the identities.